everyone, welcome back to our Ecology channel. I'm Janelle.
And I'm Sydney.
And today we'll be discussing parasitoids.
So this is just a funny depiction of parasitoids in action. On the left we have our Anaphis nitens, and on the right we have our Gonopteris scoltoladius.
Pew pew!
So this is the case study for parasitoids. So Anaphis nitens were introduced to reduce the number of snout beetles. This is because the eucalyptus snout beetles were feeding on eucalyptus trees and ultimately destroying them and depriving the land of this resource. So the parasitoid Anaphis nitens will invade the snout beetle by implanting their eggs into the beetle. This will allow for the parasitoid to reduce the number of snout beetles while reducing their reproduction rate and increased mortality rates. This is a typical vicious cycle of parasitoids on their host. The picture shows the healthy eggs of a snout beetle on the left, and on the right are the eggs that have been infested with a parasitoid, which resulted in their death.
So the snout beetle's nickname is the eucalyptus weevil, and they're an indigenous species to Australia but can be found anywhere that the eucalyptus plant thrives. A high population rate of these beetles is known to cause heavy damage on vegetation. So the female snout beetles reproduce multiple times throughout their lives, and they lay their eggs on batches of surfaces of the leaves. These species of beetles is known to be generational, which means there's typically more than one generation living per year. For the female, lives for about 3 months, whereas the larvae development takes about 30 to 80 days. As for the Anaphis nitens, they're an internal parasite of the insect eggs. They complete their metamorphosis process within the host eggs. The egg parasitoid of the Anaphis nitens has been introduced to many countries as a biological control agent. For 1996, parasitism was so intense that 80 to 100% of the eggs that the snout beetle became totally extinct, and as a consequence, the Anaphis nitens disappeared. So on a smaller scale, positive density dependence was detected, whereas parasitism was low, and inverse density dependence, where parasitism was high.
So this is background information on parasitoids. So how does a parasitoid invade and survive in their host? So a parasitoid will need to be able to evade the host's internal mechanisms. So the larval stage usually does the most amount of damage to the host. So once inside, the parasitoid will need to evade or counter any defense mechanisms from the host. This can usually be done by altering the physiology of the host. So how do parasitoids kill their host? Well, typically the parasitoids feed on the host, so their living tissue that they reside in, and use it as their energy. All of the damage that the host endures and the emerging of the parasitoid will ultimately lead to the host's death. So what factors may affect the parasitoid? Temperature can affect parasitoids because parasitoids have a small range in temperatures that they can endure. So if it exceeds outside of this range, it can usually result in death. Competition is also a factor between the host and the parasitoid for their fight of survival, and this will usually only result in one of the species surviving. What is the cost and benefits for parasitoids? So parasitoids will look for the host that is most beneficial for reproduction and survival rate of their larvae. The benefits for this host are using the resources inside the host for growth, protection, and completing their life cycle. The cost is not finding a suitable host or the host using its defenses to survive the parasitoid. This could affect the survival rate of one of the species or both.
For our host defenses, some species of the parasitoids has its own defense mechanism known as encapsulation, which is a cellular defense reaction in which many hemocytes surround and isolate any foreign material that involves the hemocyte. So this may depend on toxins within the body that does not harm the host but is toxic to the parasitoid. This may lead the parasitoid not be able to emerge from the host or death. So several host systems survive and sustain the parasite by using the energy that would have been used for reproduction, and the parasite growth is caused by diverting energy from reproduction to the host and parasite growth, sometimes even causing giantism in the host.
This is the end of our discussion of parasitoids. I hope you all enjoyed. These are our citations for where we gathered some of this information. If you have any questions or comments, please leave them below.